Hello students, in this lecture we are going to discuss some application of maximum and minimum of a function in physics, and it's a very important concept while dealing with various topics of physics. So first I am going to solve the question that was given in the last lecture, and you must have tried that question. If you get the solution, it is good, otherwise you can just follow what we have discussed in the previous lecture. So here the function that was given to you was y is equal to sine x, and in the previous lecture Subbu sir has told that there are two methods by which this question of maxima and minima can be solved. One is by the method of differentiation, the steps we will following here, and the second is by drawing a graph. The graph details we will discuss on some other lectures, but it's a simple graph, so we can solve this problem with the help of graph also. So first I am going to discuss this with the help of the method of differentiation. Now dy by dx is the first differentiation of this function y. So as you know from the previous lecture that the differentiation of sin x will give us cos x. So the first step was to equate this value to 0. The interval that was given to us in the previous lecture was between 0 to 2 pi. Now as we know that value of cos theta is 0 when the value of theta, which is x here, is either it is pi by 2 or it is 3 pi by 2. So at both these value x is 0, so we have to check the function at x is equal to pi by 2 as well as at x is equal to 3 pi by 2. Now the second step was to double differentiate this function, or we can write it as d2y upon dx square, and this is dy by dx of this function, that is cos x, and this will give us minus sine of x. Now whether the function is maximum at pi by 2 or minimum at pi by 2 or maximum at 3 pi by 2 or minimum at 3 pi by 2 can only be solved if we put this value of x in the equation. So when we put x is equal to pi by 2, we will get minus of sine pi by 2, which is minus 1. When we will put x is equal to 3 pi by 2, we will get plus 1. Since this term, as minus 1, is less than 0, so at this value, when x is equal to pi by 2, at this value, since the function is negative, so y is equal to sine x will have its maximum value. So the function will have maximum value here, and since it is positive, so at x is equal to 3 pi by 2, the function will have minimum value. Now we can also calculate the maximum and minimum value. So to calculate that value, we will put x is equal to pi by 2 in this equation. So what we will get is y is equal to 1. And when we put x is equal to 3 pi by 2, we will get minus 1. So here you can see that
the local maximum value is 1 at x is equal to pi by 2, and local minimum value is minus 1 at x is equal to 3 pi by 2 in the interval 0,
0 to 2 pi. So if in other interval we may have other maxima and other local minima as well.
In fact, if you remember, the graph of sin x is basically very well known graph, which is something like this between 0 to 2 pi. So from graph also at pi by 2, which is actually 90 degree, the maximum is coming, which is 1, and at 3 pi by 2, the minimum is coming, which is actually minus 1. So both the methods are quite simple here and easily relatable.
Yes. Or when we discuss graph in detail, then students can even draw a graph of complex function also, and using that graph they can solve complex equation of maxima and minima as well. So that we will discuss in some other lecture, and then we will come to that point. So here I am also going to discuss one very important application of method of maxima and minima in physics. So you all have heard a term that is equilibrium. So what is the meaning of equilibrium? When a system is in equilibrium, it must be the case where the value of energy of the system is either it is maximum or it is minimum. In both the case, the system is said to be in equilibrium. There are three types of equilibrium. One is called stable equilibrium. The other is called unstable equilibrium. And the third one, which is called neutral equilibrium as well. What is the meaning of a stable equilibrium? Stable equilibrium means when the system has its minimum energy. So if I write U as energy of a function, then the stable equilibrium means the potential energy of a function of a system is minimum. Now, unstable equilibrium means when the potential energy of a given system is maximum. So you can simply relate the condition of stable or unstable equilibrium with the condition of maxima and minima that we are going to discuss in this one example here. Sorry, this is maximum. And when neutral equilibrium means U is equal to not 0 but it is constant. So these three things can also be discussed in terms of force as well. In all the three cases, the value of force should be equal to 0. Whether the equilibrium is neutral or it is the equilibrium is stable or it is unstable, the force in each of these cases is 0. The value of energy can be either constant, maximum or minimum, and we are going to discuss this with the help of an example.
So if I remember in one of our previous videos, you have told students that potential energy and force are related.
Yes.
Like this, that force is equal to
minus du by dx.
du by dx. So I think you are going to again use this concept.
Yeah, I am going to use this, and using this you can simply see how the condition of equilibrium is related with the method of maxima and minima. So I am going to take one very simple example. Let us say the potential energy of a given system is given as 2x cube minus 3x square plus 1. Now we have to calculate the value of x at which the energy is maximum or minimum and the actual value of potential energy at those value of x. So I will ask Subbu sir to just describe this equation and how to solve the question here.
So basically, if I differentiate this potential energy with respect to x, which is actually displacement here, so we will get that it is 3 into 2, 6x square, and then we get minus 3 into 2, 6x, and this would become 0. Next, we have to equate it to 0 if we want to get the maximum or minimum potential energy. So this is the first step we studied in the previous lecture.
And from this equation, we can also say that it is a value of minus f is equal to 0 or f is equal to 0. So this is giving us a condition where force is 0 or this is the du by dx rate of change of energy here.
So if we find out now the values of x by solving this equation, so we can easily see by taking common x, we get one value as 0 and another value as 1. Now, which values of x giving you the max stable equilibrium or unstable equilibrium? So we will further differentiate this function, which is actually d2u by dx square, and we find out that it is 12x minus 6 on differentiating. When we put 0, it is minus 6. So we can say that when we are putting 0 over here, we are getting minus 6, which means a negative value.
Yes.
So we say that double derivative is coming out to be negative if we put 0, which means that this is the situation when we have the maximum potential energy. So the system is unstable here. Am I right, sir?
Yes, yes, definitely.
And if I take x is equal to 1 over here and put it here, we get 6, which means double derivative is positive. So the system is in a stable equilibrium
Because energy is minimum here.
Energy is minimum.
So just you have gone through this concept and you can see that the condition of equilibrium is very important, especially in mechanics, and it is the foundation of mechanics. So whether the system has a type of equilibrium which is neutral, stable or unstable, you can always find out simply by using the method of maxima and minima that we have learned in the last 2 lectures. So from the next lecture we will discuss some more interesting concepts, and I am just giving you one question based on what we have learned in the last 2 lectures. You have to solve this question and you can comment in the comment section of our video. So a function, I am writing work done by a force is given let us say by a function that is some constant k upon cos theta plus mu into sin theta. Mu is some other constant, you can treat this mu as a constant here. So what you have to do is you have to calculate the minimum and or maximum value of work done in the given set here. So theta can lie between 0 to pi. Theta as an interval of 0 to pi. In this interval we have to calculate the maximum or minimum value of work done, and this question we will discuss in the next lecture. So thank you student.